Okay, Bismillahirrahmanirrahim. Okay, folks, welcome back. We are with the 11 plus class here. Numerical reasoning, short test 10, CEM Durham University style papers. Okay, we're going to go through this test paper question at a time. So let's the next page then. Okay, give me one moment while we get the first page loaded up. Right, okay, let's make it a little bit bigger. Oh, that's better. Okay, right, folks, we are live now, so please behave yourselves. The following questions are based on the number sequences below. Okay, let's get a nice color. Okay, let's get a nice size. Okay, but how much does each term in sequence A increase to give the following term? So they want to know what is the increase between these numbers, and the answer here is
5. It increases by 5 with the time.
So it increases by 5 each time. Thank you. Okay, so the answer here, even though they got two boxes, we just need to write down here 5. We don't need to write down 0, 5. That's unnecessary for the moment.
That's only for decimal.
Okay, how many triangular numbers are present in the terms given in sequence B? Now, sequence B is now talking about this sequence here, which starts here. Now, triangle numbers. Can someone tell me what the triangle numbers are first? What are the triangle numbers? And the first triangle number is 1, and then
3,
then 3, then
6,
and then
10,
and then
15,
and then
21,
okay, and then
36.
after 21 is 36.
Um,
So we're adding 6, then we're adding. I'm going to be adding 4, 5, 6, adding 7, isn't it?
28.
Okay, I thought I was going to say something else. Okay, right. Any more? Right, let's have a look. If you look over here, the number 3 is present, which matches that triangle numbers. What else is there that matches?
6.
And 6 as well. Any more that match there?
No.
Okay, so only 2 match, and so none of those match. Okay, let's go down a bit. Let's scroll the page down. What is the next term in sequence B? Okay, I think we might need to make this a little bit smaller because we can't really see it properly. Can you guys still see it? Is it too small now?
No. It's good enough.
Sure.
Yep.
What we can do, we can expand this over here and then use some space on the side for writing on.
Rock, paper.
Yeah.
Paper, scissors.
Okay, what is the next term in sequence B? So we have 3, 6, 12, 24, 48. What's actually happening here? Let's make this space bigger. Like, you know.
Just doubling.
So we are doubling the pattern each time, is that right?
Yeah.
So for this one here, we're going to have now 48, then times that by 2, and that will give us
96.
96. What is the range of the terms given in sequence B? So the key word here is range. Range means, Mr. Musab.
Biggest number, take away the smallest number.
Okay, so in sequence B, what is the biggest number?
48.
48. And what is the
Smallest
number?
3.
3.
And
48.
Equals 45.
45, lovely. What is the next term in sequence C? Let's have a lishbah for this one. So, in sequence C, the pattern is what? What's the pattern for this one? Pattern is, what is the lishbah?
Divided by 3.
Dividing by 3. So, divide by 3, 3, 3, 3. Now, what's 3 divided by 3? 1. So, even though here they've got decimal points, I don't even know what the purpose of that is.
Let's just
So,
check you out.
yeah, so the answer we just write as 1.0 in that case. Has everybody got those answers so far for question number 1? Okay, let's move on to question number 2 now.
Yeah.
6, 9.
Yeah.
Just give me a moment while you get the next page up. Alright, the diagram below shows a trough. What they have in farms and stuff, that kind of shape. It's a long thing of water used by animals on a farm. The cross-sectional area is 800 centimeters squared. The cross-sectional area is talking about this part here at the front. So this here has an area of 800 centimeters squared. Okay, and the length of the trough is X meters long. So they've told you here that this length here, oops, slightly not straight there. So that is X meters. Okay. Now, remember we've already got different units, haven't we? That's in centimeters squared, and that's in x meters long. So if the maximum capacity of the water trough is 160,000 centimeters cubed, what is the value of x? Well, that's okay. The answer here is in centimeters anyway. So what do we do for question 2a? Any ideas what we do? Go on, Mr. Moise.
160,000 divided by 800.
Okay, let's have a look. Let's have a look at the mathematical idea first. Right, let's expand this part here a bit to the end. Right, here we go. Now, what do we know about this kind of question? Where's my pen? If I can see my pen, it'd be nice. And make lines. Oh, there it is. Found it. So we said the volume of a prism is always equal to the area of the cross section multiplied by the length or the thickness of the shape. So now we've been told the volume. What is the volume?
160,000.
160,000. Let's put everything into context. So 160,000 goes here. The area comes from here, which is 800. That goes there. And the length in centimeter will go here, the L. Now we need to work out the L value. So 800 times by something is 160,000. Now opposite of multiplying by 800 is?
Dividing.
So we have to solve this equation here. Okay, let's so opposite time by 800 is? So we have here, let's do on the side over here, 160,000 divided by 800. Now, so we can divide that by 10, divide that by 10, divide that by 10, divide that by 10, oops. And we can divide this by 8 and divide that part by 8. So that leaves you 2 and a 0 and a 0. What's 2 and a 0 and a 0?
200.
So 200 centimeters, and that is the correct answer. Right, tell me if you use that formula volume equals area time by the. So put your hand up if you use that formula. One person. Okay, right. Let's move on. Right. Right. Question part B. If one pig requires 5,000 centimeter cubed of water per day, for how many pigs is there sufficient water in a full trough? So what we need to do now, we need to do the same calculation that we did earlier. Rather than dividing by 800, we're going to divide it by 5,000. So we still got 160,000, but this time we're going to divide it by 5,000. 5,000. So let's do that. So we divide that top by 1,000, divide the bottom by 1,000. So we now got 160 divided by 5. What's 160 divided by 5, folks?
90.
What does it give you?
30.
32. Well done. So there's enough for 32. Okay, let's move this down a bit. So the answer here would be 32. If one horse requires 40,000 centimeters of water per day, for how many days is there enough water in a full trough? For how many days now? Hang on a second. So what would, okay, then if it's, so Mr. Bilal thinks it's easy, can you go through the calculation with us? What do we do?
Basically, 160,000 divided
I like the way you say it basically. It sounds really basic, yeah. And then divide that by?
by 4,000.
40,000. What do we do with this? Arva, what do we do? Are we looking at the work or have you done this work right?
Yeah.
So why aren't you paying attention then? So we divided the top by 1,000, by the bottom by 1,000, divided by 10 again. So we now got 16.
4.
16 divided by 4.
Yeah, which is 4.
Which is just 4. Okay, so that gives you 4 days worth of drinking for one horse. If you haven't got this work right, you need to be copying up the working out in your notes. Okay, the farmer has 5 identical troughs to the one shown in the diagram above. What is the total volume of water you can fill up the troughs with? Let's have somebody else. Let's have Ikra. Ikra, can you give us a calculation for that one, please?
So, there are 5
Troughs.
Yeah.
So, how much is each trough?
Each trough is is
160.
1,000.
And how many of them does he have? 5 of them. So he's got 5 of them. We do 160,000. We multiply it by 5. What does that give us? Mr. Moyes? 800,000. Okay, 800,000 centimeters cubed. Lovely. So that's a nice straightforward calculation. Next, if each trough costs £538.75, what is the total cost of all the 5 troughs? Now, let's do a calculation. So we got, so we got 538.75, and then we're gonna, okay, let's get rid of that last line for the moment. And we could just start straight and multiply that by
5.
Let's just do it right here. So, and then we got 2 decimal places in the question. So we'll have 2 in the answer. What's 5 times by 5? First one, Mr. Bilal. 25. What's 7 times by 5? Add 2.
27.
What's 8 times by 5?
40.
Add 3.
43.
What's 3 times by 5?
15.
Add 4.
19.
And what's 5 times by 5?
25.
Add 1.
26.
So the answer will be 2, 6.
9.
Okay, I think I've put my 2 and 6 in the wrong. I put my 2 in the wrong column, wrong box. It's okay. We just go back and do that.
It's the same thing. 12.
Okay. What's missing here?
It's meant to be. Start that column is meant to be used.
Start here.
Yeah.
So I think they give us extra columns.
It's confusing. You're trying to.
It's not confusing. You just got to use your brain.
No, they confuse you.
Okay. 2693.75. And that's the end of. Is that question 1 now?
2.
Question 2. Wow. Question 2 is already finished. Lovely.
Wow.
Let's move on to question number 3.
Number 3.
Okay, here comes question number 3. Let's. Okay, no, that seems to be the same one. Okay, 771. Just give me 1 moment, folks. Here we go. Okay, question number 3. For 5 consecutive days,
So this consecutive.
means one after the other. One after the other. Jason brought 3 strawberry sweets and 2 orange sweets. Whilst Brian bought 4 lemon sweets and 1 orange sweet. Okay, right. What is the total number of sweets Jason and Brian bought over the 5 days? So we got 3 and 2, 4 and 1. So we got 3 and 2 and 4 and 1. That's done here. And we've done that over 5 days. So what do we get? What does this first part give us? 3, 7, 9, 10.
Times by 5.
Okay, so that gives you 10 sweets per day. Times by 5.
50.
Okay, miss.
50 finale.
Okay. Okay, remember, Bilal, we are recording this session. It is live session. Can you please, keep your comments which are appropriate for the lesson, please? Thank you very much. What fraction of the overall sweets they bought are lemon flavored? Yeah, lemon.
Lemonade.
Okay, now how many were lemon? So 2 orange, 4 lemons. So they bought 4 lemons per day for 5 days. So how many lemons were in there?
20.
Okay, so we had. Okay, we'll get my mouse back. Oops. We had 20 lemons out of how many? 50. So we divide that by 10, divide that by 10. That gives us a nice clean answer of 2/5. Okay, if the children collected the sweets they bought in a bag and chose one randomly, what is the likelihood of it being orange flavored? Okay, so now, so the probability of being orange flavored is going to be how many orange ones there were out of the 50. Is that right? Right. Let's work out. Let's go back up a bit. And see, like there were 3 orange per, how many oranges per day? Well, they got 2 orange on the top first and 1 orange on the bottom one. So it's buying 3 oranges per day one day. So 3 times by 5 is, so 15 oranges. So it'll be 15 out of 50. Okay, last question was it 3C? Was it 3B? 3C. Okay. Ah, it wants you to make it into a percentage now. Probability is normally done as a fraction, isn't it? It can be given as a percentage, it can even be given as a decimal. So now, if you want to change this fraction quite easily into a percentage, you can do that quite nicely. Go on, Alicia, tell me how we do that.
You times 15 over 50 times it by 100 over 1.
You can't do that way. Times it by 100. Or you can make it double top and bottom. Yeah, but never mind. So now we can cancel diagonally. So 50 divided by 50 is 1. 100 divided by 50 is 2. So on the top we have 15 times by 2 is, and 1 times by 1 on the bottom is 1, not 2. And 30 divided by 1 is 30%. So if you want to change any fraction into percentage, you multiply it by 100 over 1, or you make it equivalent to 100. And then you read off the top number. Okay. Next. What is the ratio of strawberry to lemon sweet purchased by the boy? Strawberry to lemon. So let's go up. Yeah. Okay, now strawberry was 3 strawberries per day, and lemon 4 lemons per day. Is that right? Yeah. So 3. No. So for every 3 strawberries, they bought 4 lemons. Okay, do we need to actually work out that is the ratio, isn't it?
Yeah.
That's the answer. 3 to 4. If the children remove all of the lemon sweets, what is the probability of a randomly selected sweet being strawberry flavored? How many lemons were there, by the way?
20. 20.
Let's have a double check. Oh. Okay, Mr. Bilal, can we focus in the lesson? So we're looking for lemons. How many lemons are there? Yeah, 20. That's right. Okay. So, I've got a line there. Let's go to that line. So we got 20 lemon sweets are taken out. So how many do we have in the first place? 50. So 50 minus the 20 is equal to? 30. So we have 30 sweets left. So it's out of 30 now. So it goes, what's the probability of getting strawberry flavored? How many strawberries are there?
15.
15. Okay. And this answer, do they want this also as a percentage?
Yes.
Okay, 15 over 30, times that also by 100 over 1. Okay, so now, remember you can cancel vertically as well. So 15 divided by 15 is 1, 30 divided by 15 is 2. Then you got a half times by 100. What's half times by 100?
50%.
50%. So the final answer is 50%. Okay, right. Let's move on to the next question. All done. Question number 4. The scale on the right shows 15 spheres of equal mass on a weighing scale. What is the total mass of the sphere on the scale? Okay, so we look at the scale and the answer one.
9 kilograms, but you converted 9,000.
Okay, so that's 9 kilograms. We've got to give it into grams, so we've got to times that by 1,000. So the answer works out to be 9,000 grams. Okay, how much does each sphere weigh? How many do we have? 15.
Yeah.
So for the next calculation is 9,000 divided by 15. So let's cancel by what we know will work. So let's do 9 divided by 3, which is 3. 15 divided by 3, which is 5. So we're going to have 3,000 left over on the top.
Yeah.
Divided by 5. Okay. Now 3,000 divided by 5 will give you a nice lovely answer of 600. What fraction of the spheres are black for part C?
That's easy.
Okay, you need to stop saying that because you're annoying me now. Okay. There are 4 black spheres. How many black spheres are there in total? How many are there?
4.
4. So we have 4 black spheres. So it's going to be 4 out of the total. What's the total?
15.
Now, can that be cancelled down by the way?
No.
No.
No, because both of them don't divide into the same.
That's right. So we leave that as 4 over
15.
15. Lovely. Okay. When a cube is added to the scale, the total mass increases to 9.8 kilograms. How much does the cube weigh? Now, it was originally 9 kilograms. It went up to 9.8 kilograms. So we've added on 0.8 kilograms. Now to change kilograms into grams, what do we do? So that will give us an answer of 800 for that one. Nice and straightforward stuff. So far. What is the ratio of black to grey to white spheres? Okay, right. How many black spheres are there? How many black ones do we have? 4. How many grey ones do we have?
6.
And the other ones? 5. Now, can we cancel it down? Another 4 and 6 will cancel because they want all 3 of them cancel. Because they want all 3 cancel. That's it. We can't do anything more than that. And that's the end of that question. That's the end of question number 4. One more question left. So let's go on to that one. 773. Okay. Question number 5. Okay. If Jude is 150 centimeters tall, approximately how many feet tall is he? Now, what do we know? So, about conversion, remember this is this here, this measurement. Okay, let's get a. Okay. This measurement is a metric measurement, and feet is called a imperial measurement. Okay. So we need to know the conversion between centimeters and feet. Now, what do we know? We know that, for example, that 1 foot is equal to how many inches? In 1 foot, how many inches do we have? Put your hand if you know how many inches in a foot. Go on.
10. 12.
So 1 foot has 12 inches in it. Okay. Now, how in 1 inch, how many centimeters in 1 inch?
2.5.
Well done.
I learned that today.
Okay. So each inch. So we need to change centimeters into inches and inches into feet. Okay. So that's our conversion here. Facts here. So question 5A. Also, there's another like a rough conversion as well. We know that we also know that 1 foot is equal to, now what's 12 times by 2.5? 30 is
24.
Yeah, so we can also use that conversion as well. So 1 foot is equal to 30 centimeters. So this conversion here comes from these other earlier 2 conversions. So now we do 150, we divide it by 30. So 150 divided by 30 will give us 5 feet.
5.
Okay, right. I've kind of slightly covered up with it. If Ryan is, what's that number there, folks? 13. So if Ryan is 13 30ths of Jude's height, what's Jude?
Jude is a boy. 50 centimeters.
150. To work out the off mean, what's off mean in maths? Times. So we have to do 13 over 30 times by 150. So we're working out a fraction of 150. Okay, let's work that out. So again, so divide that by 10, divide that by 10, cancelling diagonally. Divide that by 3, divide that by 3. So we're left with 13 times by 5 on the top, which will give us an answer of
65.
Well done. That's the answer. Okay, lovely. So far, so good. If Jude's mother is 5/6 of Jude's height, what's Jude's height? Remind me, please.
150 meters.
Okay, C. Okay, let's go for that. So now, can we cancel the 6 and the 150? Go on.
Can't you just do 150 divided by 6 then times by 5?
That's exactly what we're doing. That's one way to do it. That's the manual way. But we simplifying by sight here. So 6 and 150, they will both divide by what? 3. So what's 150 divided by 3? 150 divided by 3 is 50.
Oh, yeah.
Okay, now you got 5 times by 50, which is equal to,
250.
and then 2 times by the invisible 1 over here is 2. So you got 250, and then we got to divide by 2,
which is 125.
Thank you.
0.
Thank you. Okay, the ratio of William's height to Jude's height is 6 to 5. So William to Jude is 6 ratio 5. How tall is William? Okay, now what's Jude's height? We just work it out. 125, isn't it?
Yeah.
So let's try to figure out how does the 5 become 125? What will happen to it? Times by 25, isn't it?
Yep.
So that's the ratio. So how did this ratio become the answer here? So 6 ratio 5 became something ratio 125. Yeah? So the 5 to 125 is times by 25. 5 times by 25. So what we do on the right hand side, we have to do on the
Left hand side.
So you got 6 times by 25, and that will give us 6 times by 25.
150. Yeah.
Okay. Are you sure it's 150?
Isn't it? No. Yeah, it's
Because 25 times by 2 is 50, and then times that by 3 is exactly 150. Okay. Which question are we on now? 5D. Okay, you want to go. Okay, folks, I've copied down the wrong numbers. Just a little mistake there. We're going back to undo some of the stuff. Okay, let's undo some of the stuff. Okay, just give me one moment while I undo some of this. Mr. Bilal, remember I told you? Okay. Jude's height, we said it's copied down as 125. Actually, Jude's height was 150. Thank you for that quick correction there. So that should be 150. So now let's restart that question. Sorry about that mistake there, folks. So 5 to 150. Or how do you get from 5 to 150? Times by 30. So 6 times by 30 will give us 180. Okay, right. Right, an equation to calculate Maria's height m. So there's Maria's height m, which is here. In centimeters from Jude's height in centimeters from below. Use the equation to work out how tall Maria is. Now let's get Jude's correct height. What's Jude's correct height? 150. So if we put, I'm just going to write over here, got more space. M is equal to that. That's too light. Okay, let's do it. M is equal to, what's 0.75? 0.75 is really 3/4, isn't it?
Yeah.
So 3/4 times by Jude's height. What's Jude's height?
150.
150, yeah? Plus the 20. So what's 1/4 of 150? So 1/4 of 150 is divided by 2, isn't it?
Yeah.
So 150 divided by 2 is 75.
37.5.
Okay, so this part here will give you what? So 3 times by 37.5 and then add the 20. Okay, and that will give us a total answer of, when you finally finish that calculation, is 132.5. And that's the end of the paper, folks. Done?
Yeah.
All done? Okay, folks, apologies for that, copy that wrong number there. So that's all done now. Thank you very much for joining us on our journey through this maths paper.
It was a long
Okay.
journey.